solve the system linear equations using matrix method, you know that first of all we'll write the system linear equations as matrix equation. So what is the quotient matrix? 2, 1, 3 in the first column, and 3 minus 2 minus 1, and you have 3, 1 minus 2. Multiplied by the variable matrix x, y, z equal to the constant matrix 5, negative 4, 3. If to the quotient matrix, this quotient matrix I denote by A multiplied by x, y, z equal to 5 minus 4, 3. And multiplying both sides by A inverse, you get x, y, z. Rather pre-multiply will be better to say. So x, y, z equal to A inverse times 5 minus 4, 3. Call it 1. So now it is just a matter of finding the inverse of the quotient matrix A and substituting in 1. So let us work out A inverse. What is your quotient matrix A? Quotient matrix A is 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. What is the definition of? The definition of A inverse is 1 by determinant A into adjoint A. So let us first work out the value of determinant A. Let us expand along R1. So you get 2 times, delete the row and column through 2, you get 4 minus plus 1, 2 times 4 plus 1. And you know the sign convention, plus minus plus. So it should be minus 3 times, delete the row and column through 3, you get minus 2 and minus 3. And then plus 3 times, delete the row and column through 3, you get minus 1 minus plus 6. Just work it out and you get 2 into 5, that is 10, and minus 3 into minus 5, so you get plus 15, and you get 5 into 3 again 15, so 15, 15, 30, 10, 40. So what is the value of determinant A? The value of determinant A comes out to be 40. And now next we have to work out the value of adjoint A. And how do you work out the value of adjoint A? It is the transpose of cofactor matrices, that each element is to be replaced by cofactors, say C11, C12, C13, C21, C22, C23, C31, C32, C33, and take transpose. And how do you work out a cofactor? Delete the row and column through that element, work out the value of the remaining determinant of 2 by 2 order in this case with proper sign, plus minus plus minus plus minus plus minus plus, impose these signs. So let us work out. You get for C11, delete the row and column through 2, you get, and of course plus times, you get 4 minus plus 1, 4 plus 1. And then minus time, delete the row and column through 3, you get minus 2, minus 3. And then plus times, delete the row and column through 3, you get minus 1 and minus plus 6. And now repeat the process with the second row. So you delete the row and column through 1, and of course don't forget to write minus sign outside. So minus times, you get minus 6 and minus plus 3. And now you just work out rest of the elements. You will get plus times minus 4 minus 9, minus times minus 2 minus 9, elements of the third row, plus outside 3 plus 6, and minus outside 2 minus 3, and plus outside minus 4 minus 3, and transpose of it. Don't forget to write transpose. So now work out and then take transpose. When you work out, you get, by the way, 5, 5, 5, and 3 minus 13, 11. Elements of the third row are 9, 1, minus 7. Take the transpose and you get adjoint A. So adjoint A is, write the elements of the first row, 5, 5, 5 in the first column, that of second row 3 minus 13 11 in the second column and 9 1 minus 7 in the third column. So we have got adjointing, and that way in turn we get A inverse as 1 by determinant A into adjointing. Determinant A we worked out as 40, so it is 1 by 40 times adjoint A is 5 3 9, 5 minus 13 1 and 5 11 minus 7. And now replacing this value of A inverse in 1, you get x, y, z equal to 1 by 40 times. The value of A inverse is 1 by 40 times 5, 3, 9, 5, negative 13, 1 and 5, 11 times minus 7 multiplied by constant matrix which happened to be 5 minus 4, 3. And now let us take the product. So it is on the left you have x, y, z, the variable matrix equal to 1 by 40 times multiply row to column, you get 25 minus 12 plus 27, then multiplying with the second row you get 25 plus 52 plus 3, and then with the third row multiplied to the column you get 25 minus 44 minus 21. Just work it out. So it is 1 by 40 times 40, 80 and minus 40. Multiplying each element by 1 by 40. On the left you have a column matrix XYZ. On the right, multiplying each element by 1 by 40, you get 1, 2, minus 1. Equating the value of corresponding elements in the two matrices of the same order, you get x is equal to 1, y equal to 2, and z equal to minus 1. That is the required solution.